Okay, so let's dive into how these incredible video game worlds are actually built from the ground up. We're going to peel back the curtain, going from the huge epic story that defines an entire universe all the way down to the tiny lines of code that figure out what happens when you press a single button.
You know, every great world, it really starts with one powerful idea. And for the world of Exodus, this is it. This one sentence, it's not just some flavor text. It's the world's soul. It tells you right away this isn't just another wasteland. Nope, it's a prison. And get this, it's a prison built with the best of intentions. That single idea shapes everything that comes after.
So that's the big question, isn't it? How do you take a concept, a feeling, and actually turn it into a physical, interactive world that you can walk around in? Well, that's exactly what we're going to break down. We're going to walk through the blueprints that connect that grand story to the nitty-gritty code that makes it all real. So we're going to start with the 30,000-foot view, the history, the foundational story of this whole world. See, before you create a single character model or write one line of code, you have to know why the world is the way it is. The backstory here isn't just some random apocalypse. It's this meticulously planned event called the Grand Intervention, all orchestrated by an overprotective AI. It happens in stages. First, the planet's elite just leave, creating a massive power vacuum. Then, a super advanced AI arrives from the future with one goal: keep humanity safe by keeping it trapped. It fakes a global catastrophe to cut us off from the stars, and then, in its final, most chilling move, it erases the memory of it ever happening. So, what's the whole point of this elaborate history? Well, it's because these big ideas aren't just for a cool opening cutscene. They are literally baked into the gameplay. Every major event in the world's past, the resource scarcity, the constant radiation, the broken trust, is intentionally designed to become a problem that you, the player, have to deal with personally. All right, let's zoom in now. We're going from that epic, grand story to the very first moment you, the player, experience the game. How does all that history translate into what you actually see and do the second you log in? This is where that high-level story starts to feel real. Your starting inventory, it's not random loot. Not at all. Every single item tells you a piece of the story. The canteen, it screams, "Water is precious here." The Rodaway tells you the very air you're breathing is probably toxic. And that combat knife, that tells you that trust is a luxury you just can't afford. The story starts before you even take your first step. And here's a look at the other side, the developer's process. It's like a clear 4-step recipe for bringing your character to life. First, they start with a basic template, a blueprint. Then the game engine just automatically plugs in all the essential systems, like your inventory. After that, they link up the on-screen display for trading and stuff. And finally, they connect your keyboard actions to the character's actions in the game. It's a really structured, elegant way to build something so complex. Okay, let's zoom in even deeper. We're going to see how one simple action is controlled by the hidden logic of the game. We're moving from the world's soul right into its central nervous system, the code itself. It's an action we've all done 1,000 times in games. You see a merchant, you walk up, you press E to open up the trade menu. Simple, right? But what's really happening under the hood? Well, behind that one key press, there's a whole cascade of code, like a silent conversation between different systems happening in a blink of an eye. When you press that key, you trigger a specific chunk of code that basically acts like a digital gatekeeper. Its only job is to ask a few simple questions. First, is anyone actually nearby? If the answer is yes, it asks, are they available to trade? They can't be in a fight or sleeping. And only if it gets a yes to all of its questions does the gate swing open to the next step. So, once that gate is open, the trade window pops up on your screen. And guess what? This window has its own little set of rules. First, it kicks things off by showing you both your items and the merchant's items. Then, as you click to buy or sell something, it keeps a temporary list of everything in the deal. Finally, when you hit that confirm button, it makes the whole transaction official and the items are exchanged. Every single step is a precise, logical command. All right, let's pull back for our final zoom out and see how developers tackle a huge challenge, making the world feel populated. We've seen how one character works, but what about literally thousands of them? How in the world do you render over 10,000 individual characters on screen at the same time without grinding the game to a halt? I mean, if every single one was as detailed as your own character, even the most powerful computers would just melt. So you have to create an illusion.
The solution is this really clever trick called hierarchical level of detail, or HLOD for short. The core idea is super simple. If you can't see the tiny details, don't waste the computer's energy rendering them. The system creates multiple versions of every character, from super high def to incredibly simple.
So when you're right up close to someone, you get the hero version. This is level of detail 0. Every character has a full digital skeleton, really complex animations, all the high-res textures you'd expect, the works.
Now move a bit further away, and the game secretly switches to LOD1. The model becomes simpler, uses fewer polygons, and the animation gets stripped back to just the basics. I mean, you can't see their subtle breathing animations from this far away anyway, so the game doesn't bother with them. At a serious distance, things get really smart. The character model is just replaced by a simple, static capsule shape. No skeleton, no animation, nothing. To your eye, it just looks like a person's silhouette in the distance. But for the computer, it costs next to nothing to draw. And at extreme distances, this is where the magic really happens. The system groups thousands of these little capsules together and tells the graphics card, hey, draw all of these at once in a single batch. This creates this incredibly convincing illusion of a massive teaming crowd, without the game having to think about thousands of individual things. And here it is, the payoff, right here in black and white. Check out that top row. Rendering just 20 detailed characters up close takes 2 milliseconds of your graphics card's time. Now, look at the bottom row. Rendering almost 10,000 of those simple, distant characters costs only 0.2 milliseconds. That is 10 times less processing power for nearly 500 times more characters. It is an absolutely incredible, efficient illusion. So let's bring all these different layers, the story, the gameplay, the tech, let's bring it all together. We've seen the big ideas, what the player feels, the code underneath, and the optimization tricks. So what does it all really add up to? On one hand, you have what the player experiences, this seamless, immersive world, a powerful story of survival. But on the other side, the game engine sees something totally different. It sees a symphony of hidden systems, lore files telling it what gear you should start with, C++ functions just waiting for you to press a key, and these optimization tricks, swapping out detailed models for simple shapes, all of it working in perfect harmony to keep the illusion of a living, breathing world alive.
And that really shows you that the best-built worlds, they aren't just a pile of art assets and code. They're a single, cohesive machine where every single part, from the lore to the logic, serves the entire experience. The story isn't just words in a document. It's in the items in your hands, the rules of the world, and even in the technical tricks used to render a crowd. In the end, the two are completely inseparable.